What's up, you guys? I'm going to start doing 3 examples solves of trig substitution. So let me go ahead and start with 1. First one here. Hopefully you guys see that. Okay. So we have this integral of the square root of x squared minus 1 all over x to the power of 4. So we have this type of integral, we have this type of case. So when we have this type of case where x squared is here, it's x squared minus 1, I want to use this substitution, using secant. So I want to use secant. The reason is because when I use secant square minus 1 is equal to tangent square theta. So when we have something like in a square root, it gets rid of the square root, so it'll just become a simple trig function. And so that's why we want to do trig substitutions, is just to get rid of that square root. Okay? So we will be using secant theta. Now, what is a? What is a going to be? Well, here, and this is just 1. So because it's just like a squared equal to, what, 1? A is 1, of course. 1 from here and 1 from here. So, of course, we're going to be using a equal to 1. So, in this case, So in this case, we're just going to be doing x equal to secant theta. So then our dx is going to be equal to secant theta tangent theta. So that's our derivative. And I'm just going to put a d theta here because it's just integral notation. It's just notation. It doesn't really do anything. So we'll go ahead, implement this. So, of course, we get square root of secant square theta minus 1. And this is why we use secant, so that it gets rid of the square root. And then, of course, x to the power of 4, x is secant theta. So, of course, we have secant to the power of 4. And then our dx is secant theta tangent theta. Tangent theta d theta. Okay, cool. So this simplifies to tangent theta because, trig identity, secant square minus 1 is tangent square, and so that gets rid of the square root. So we have tangent theta here. Okay, so it seems that we have, if we simplify this, we get tangent square. Let's see, this cancels out, so we get secant cube at the bottom. Okay, this is a 2. Okay, so what do we do now? Well, you can simplify this. If you want to, to make it easier for you, I'm just going to put a colon here. You can simplify this. You can turn it into sines and cosines to make it easier for yourself, right? So tangent is sine over cosine. So because it's tangent square, it's sine square over cosine square. And then the opposite, well, the reciprocal of secant theta is 1 over cosine theta. So let me just sort of repeat that. That secant theta is equal to 1 over cosine theta. So this is pretty much cosine cube. I'm just writing it this way just for abbreviation purposes. So hopefully it still makes sense. So now that we have cosine square here, so we have cosine here, cosine cube here. So this cancels out. So we have c, or I could, to make this easier, this is the same thing as sine square times c to the power of 3, and then minus 2, because cosine square is at the bottom. And it's the same thing as sine square times c, or sine square times cosine. Cool, okay. So our integral simplifies to this integral. So now we have a simple u substitution integral. So we'll just go ahead and let u equal sine theta du is equal to cosine theta d theta. So this is just what, u square, and cosine theta d theta is du. This is just simple power rule. And so now we can go ahead and turn u back to sine theta. Okay, so this is sine cube theta over 3. And of course we want it back to x. So what is sine theta? Well, let's draw a triangle first. So I'm just going to move my cursor here. So this is the same thing as x over 1. X over 1 secant theta. Okay? To make it, if you want to make it easier yourself, you can turn it into cosine. So this means that this would be like cosine theta equal to 1 over x. You can definitely do that. So cosine theta equals 1 over x. We draw a triangle. This is theta here. We always put theta here at this position just for convenience sake. And then, so cosine theta is adjacent over hypotenuse. So 1 is adjacent over hypotenuse x. And then if you do the Pythagorean theorem, you should get something like x squared minus 1. So now that I'm just going to color this red so that you know where the triangle is, because everything looks a mess. Okay, so now that that triangle thingy is easier to see, so let's go back here to the answer. So sine cube theta. So sine theta is, what does sine theta equal? Well, sine theta is opposite over hypotenuse. So wait, opposite. Oh, I'm sorry, I did the triangle thing wrong. I just realized. So this is not adjacent. This should be the other way around. So adjacent is here. So this is adjacent. This is the this is opposite, which would be x squared minus 1. Yeah. Okay. I apologize about that. So yeah. So adjacent over hypotenuse. Then sine theta would be opposite over hypotenuse. So it's opposite. The opposite side of theta is x squared minus 1. And the hypotenuse is x. So this is sine theta. So here our answer for sine cube theta over 3. So this would be 3x cubed of, I mean, cubing this would be like x squared minus 1, 3 halves, because the exponent for the square root is 1/2. So cubing that would be 3 halves. Yeah, this is pretty much your answer. Okay, cool. Not bad. It's not that bad. We can let's do more. 2 more examples. Okay, let's do a definite integral. Okay. So inside, so with this integral here, we have this type of integral where the x square is here and some whatever constant is here. So we have this kind of integral. So then what trig function do we use? We will let x be using sine. So we're going to be using sine as our substitution. And of course, the reason is because when we let x equal to some whatever times sine, we do sine theta, it gets rid of our square root. Okay, so that's why we're going to be using sine theta, so that it gets rid of the square root. And of course, 1 minus sine square is cosine square. Okay. Cool. So now our next problem is, what is a? What is a? Well, we have our x is here, so we have 9a squared equal to 4. Don't let this subtraction distract you. So 9a squared equal to 4. So what should a be? Now this looks tricky, right? Because I mean you can't factor 4 and 9. So if you do get like in a rational number, it's gonna be okay. Okay. So this is square root of 4 over 9. This is 2/3. Okay. So it's gonna be okay. It'll be okay. So x equals 2/3 sine theta. This will be okay. There's nothing wrong with that. And as long as we're getting rid of the square root. Cool. So I'm just going to delete this. I'm going to move this upwards. Okay. So now we derive this. Our dx is 2/3 cosine theta d theta. Okay. So now that we have that, we'll go ahead and set up our integral. So we have square root 4 minus 9 x squared. Our x is 2 over 3 sine theta squared. And then our dx is times 2/3 cosine theta d theta. Now we have bounds. So bounds where we sort of have to be careful about. So because we're letting x equal something rather than theta equal something, it's sort of kind of working backwards. So because this is a dx, these bounds are equal to x. Okay, those are x bounds, not theta bounds. So we'll be plugging these into x. So we'll just sort of do that here. We have 2/3 equal 2/3 sine theta. This is equal to 1 equals sine theta, because I mean these sides cancel out when you divide them, or I guess divide 3/2 to both sides. So then what sine theta is equal to 1? Sine theta of what is equal to 1? Pi over 2. Or I guess you could say inverse sine of 1. What is inverse sine of 1? Pi over 2. Okay, so our top bound is pi over 2. Now, you do not have to do this. You could just leave it and then turn it back to x form. That's the only thing. Here, because I'm already solving the bounds, I do not have to turn it back to x form. But if you don't like doing this, you just want to leave it as 0 to 2/3, then you can do that. However, you have to turn theta back to x because these are x bounds. And it's a lot more work. It is a lot more work. Here, you just solve for theta. And then you don't have to turn it back to x anymore because now this is a theta bound. So now we got that. What about 0? How about x equal to 0, 2/3 sine theta. Well, sine of 0 is equal to 0, so theta is equal to 0. So we have 0 here. So now these are our theta bounds. Okay, cool. So we can go ahead and delete this. And we actually don't need this anymore because everything is in theta. And our bounds are in theta, so we don't have to go back to the x, to our x variables. Okay. You only go back to x variables if you don't change the bounds or when it's like indefinite. Okay. So now let's simplify this further. Let's see. This is square root of 4 minus 9. And then squaring this is like 4/3. No, I'm sorry, 4 over 9. 4 over 9, because 2 square, 3 square is 4 and 9. So sine square theta, then multiplied by 2/3 cosine theta d theta. Cool. And so now this cancels out. So that cancels out. So then here, oh, I don't know why I did that. So now this, I can just rewrite this. Oh my god. So the 9 cancels out, so we're left with 4 sine square theta. So we can factor out the 4, right? So then this equals to, from 0 to pi over 2. So this becomes 2, and then, so we factor out 4, and then we have 1 minus sine square theta. So then this is 2 cosine theta, because 1 minus sine square is cosine square. So this is cosine theta times 2/3 cosine theta d theta. Yes, it is what you think it is. We have to use another trig identity, one of those half angle formulas. So we have cosine square theta d theta. So we now have to use that trig identity. I'll type it in blue. It is cosine square is equal to 1 plus cosine 2 theta over 2. So we'll go ahead. This is equal to 4/3 of the integral 0 to pi over 2. 1 half plus cosine 2 theta over 2 d theta. And then we can simply integrate that. The integral of a half is theta over 2. And then cosine 2 theta, the integral of that is just sine 2 theta. And because of that 2 theta, it's going to do a chain rule. So sine 2 theta, and then divide by 2. So this gives us 4. And then pi over 2. 0. Okay. So now this equals to, well, starting with 0. Well, I'm sorry. I just want to mention 0 first, because if you plug in 0, 0 divided by 2 is 0. Sine of 0 is 0. So pretty much this is technically safe. You start with pi over 2 though. But I just want to mention 0 because 0 just gives you 0. So that's good. Pi over 2, plug in pi over 2 to theta. That's pi over 4. Again, these are theta bounds, so we could just plug into theta. So pi over 2 divided by 2 is pi over 4. And then sine of, well, 2 theta, pi over 2 times 2, that's pi, right? Let me sort of write that in orange. So sine of 2 times pi over 2 over 4. Well, when these cancels out, it's just sine of pi. Sine of pi is 0. So then this whole part is equal to 0. So technically, this is literally our answer. And then of course, like, if you plug, oh, if you plug in like 0, you know, it's just going to be 0, because 0 divided by 2 and sine of 0 is 0. So this whole thing is 0. So then this is our answer. 4/3 times pi over 4. The 4 cancels out. The 4 cancels out. God dang it. The 4 cancels out. And then so our answer is pi over 3. Very simple. Okay. Cool. Last one. So our last example is going to look like a little monstrous, but don't panic. It's going to be okay. So it looks like it doesn't have a square root, but technically, if you look at this here, that is technically a square root. So what do? Well, don't panic. First thing is we want to know what x should be. So because we have this type of case, right? This is the same thing as this, because it's addition. So when we have this type of case, we want x to be, we want to use tangent theta. Again, the reason is because we do tangent square plus 1 is what? Secant square. And that gets rid of our square root. So we will be using tangent theta. Now the next thing is, what is a? Let's solve for a. So we have 25, well, x squared is here, so that means we get 25a squared equal to 100. Again, this is going to be, oh, actually, no. It's a whole number. 100 divided by 25 is 4. So a is going to be 2. So we will be using x equal 2 tan theta. Cool. And then dx is equal to secant square theta, d theta. Awesome. So now let's go ahead and set this up. Dx is 2 secant square theta d theta. And then here, don't worry about this power. I know it's bugging you, but don't worry about it for now. 25, 2 tan theta square plus 100, right? And of course, this simplifies to like 100, or I guess I can start slowly. 25. So 2 times tan theta square is 4 tan square, right? And then this becomes 100 tangent square theta plus 100. Okay, so technically we have 2 secant square theta d theta 100 tangent square plus 100 3 over 2. Okay. So now what? Well, we can definitely factor this out and simplify it even further. So 2 secant square theta d theta, and let's see, this is 100 tan square theta plus 1. What's tangent square theta plus 1? This is what? Tangent square plus 1 is secant square. So this is all literally secant square theta. Cool. So secant square theta. Okay, so now what? So start with the root 2, okay? Because of course our main objective was to get rid of the square root. So let's get rid of the square root. So the integral 2 secant square theta d theta. Okay. What is the square root of 100? 10. What's the square root of secant square? Secant. Cool. We got rid of the square root. So now we're just left with a cube. So now this is, to simplify this even further, I mean, we could take the constants out. 10 cubed is like 1,000. And then secant square theta d theta is secant cube. Secant square cancels out, and we got secant theta left. So this is like what? This is like 1 over 500. And then cosine theta d theta. Cool, it's a simple integral. This is just integrated. This is sine theta over 500. So now we go back to here. How do we get it back to x? We want to get back to x. So this is what? X over 2 equal tan theta. Okay, let's draw our triangle here. So that theta here. So tangent is opposite over adjacent. Opposite, so x is opposite over adjacent, 2 is adjacent. And then if you do the Pythagorean theorem, you get x squared plus 4. Okay, so then our sine theta is what? Sine theta is opposite over hypotenuse. Opposite of theta is x. The hypotenuse is x squared plus 4. So our answer here is pretty much x over 500 square root of x squared plus 4 plus c, because it's indefinite. And that is our answer. There we go. So that's how you do trig substitution. Well, at least that's how I do it. But I hopefully it looks helpful and more easier to look at, and also it better memorizes to help you find which to use x for, tangent, sine, or secant. Hopefully this sort of gives you a good picture of how to do trig substitution. So hopefully that helps. So yeah.